All right, hey guys. Yeah, my name is Pathikrit Bhowmick. I'm gonna do some live coding with Scala Meta and Macros. So we'll see. All right. So about me, I've been doing Scala for a number of years. I work at a hedge fund called Coatue Management. We do big data analytics and find trading signals in large data sets. I'm also pretty much involved in the open source Scala community. I'm part of the Scala platform committee. And that's my GitHub. You can find some other software that I've written open sourced over there. So to set the expectations about this talk, it's not about how the Scala Meta internals or like the too much lineage or history behind Scala Meta. It's not about Scala Macros per se, but there's going to be obviously a lot of that. But I'm going to use Scala Meta to do something useful. So the motivation is macros in Scala Meta are really useful tools, and very few developers use it. But when they use it, the impact is huge. Like it goes into this very widely used libraries. But that should change. Everyone who's writing Scala can and should know how to use macros and when needed. And so this talk is to get your feet wet and see it's not that bad. It's pretty cool. You can do a lot of powerful things when you can write programs that can write programs. So yeah. So why macros? Like some people say, like, oh, you don't need macros. You can do anything with the language. But that's not true, because at least in Scala, like you can't do something like this, where you can write a method called debug, where you can pass in parameters x and y, and you want it to print out the variable name, like x equal to 23 in this case, y equal to hello on the command line. And there's no way to do that without using macros. You can even do some more powerful stuff. The debug macro can print out the line number. It can even print out the file it was in. So macros basically have access to the source code at compile time. So you can inject it with, which you lose at runtime. You don't know the variable names. You don't know which file it was in. But macros have access to all those information. So you could use that to make your life easier when you're writing Scala code. So what are macros? Like literally one sentence would be, macros are functions that takes abstract syntax tree programs and spits out new abstract syntax tree, a new program. That's all that's there to us. And this is one way. This is a way you can write annotation macros, which is the live coding will do. So the incantation is you just import scala.meta. You extend the static annotation. So this is coming from the Scala library. So this has nothing to do with annotations. The only two things that is new here is the inline keyword. That comes from Scala Meta. And this meta keyword, it comes from Scala Meta. And so you have the definition. It's typed any. I'll come back to that, why it's any of any. Which is in this particular case would be the abstract syntax tree of whatever you're annotating. So if you're annotating a method, you'd get back the abstract syntax tree of the method. If you're annotating a class, that's what you get back, and returns any. I know you guys like hate any, but in this case, you are supposed to return a new abstract syntax tree. And one reason it's any is because you could return anything. You could return like a variable. You can return a whole new class. You can return. You can change the annotations around. So it's not clear what the return type should be. So, but I'll get back to that in a bit. And this is how you use it. Like any other annotation, you just do at this my annotation. And in this particular case, I'm putting on a user object. That's what I'm doing. Okay. So again, there's a lot of motivation. Like if you use a lot of these libraries, they use macros at some point or another. And so you already are using macros a lot. And this is an important weapon to have in your daily programming Scala repository. So macros, for whatever historical reason, has this notion of being hard to use, kind of weird things that people who only talk at conferences do. I would say that's not true anymore, or I hope to convince you after my talk you'd believe that. And there's a very good reason for that. So before quasi-quotes, I'll get what quasi-quotes are. To write a macro, you had to do all this. So all of this thing literally represents list 1, 2, 3. And what it's doing is like, OK, the whole thing is an expression. And there is this is actually list.apply. So it's taking the identity list, and it's doing the application with parameters, which are literal constant 1, literal constant 2, blah, blah, blah. This is the reason macros got a bad reputation. Because what happens here, you are very intimately familiar with the internals of the compiler. We as programmers, we like abstractions. Why should I know what the compiler is doing? Maybe there's a different compiler for Scala.js or something. Like, I should not be aware of how the compiler sees my code. So quasi-quotes came around, and it solved this problem in a very beautiful way. We get a string interpolation, the Q interpolation, and it destructures whatever you pass into it. It's a Scala. You pass in Scala code as string, and you can destructure it, pattern match, unapply, do all the nice things that we are familiar with in the Scala world. For example, given a function, so assume that there's a def, the def fn, you can do a pattern match, which is the left side unapply feature of Scala, and you get back the abstract syntax tree of the arguments of the function, and $body would have the abstract syntax tree of the body of the function. So that's the left-hand side unapply using quasi-quotes. But you can also create new objects using quasi-quotes. If you can, you can create a new function using quasi-quotes. You can pattern match. So here I'm pattern matching for the identity function, and this is what the identity function looks like. You have an argument, and you just return that argument. So this tree would always match every identity function that ever exists. So, and it comes with nice helper utils like abort. So macros are run during the compilation phase, and you can abort the compilation if something weird is happening. Let's say I put an annotation on a class, but that annotation only works on defs, and you can abort the compilation with the line number, with a nice message. So yeah, I mean, this doesn't look that bad. So 2 years ago, I did a live coding at Scala by the Bay regarding quasi-quotes. You can go watch the video, but it's not necessary to do that to understand this talk. So for this, while I was working on it, I found these 3 links very useful. These are going to be, I'll publish my slides. You can access these links. For now, I opened them before the talk because I didn't know if I'd have internet issues. So these are the 3 tabs I've opened, which are exactly the 3 links. And I'll refer them during the live coding part, so you'll see how I use those 3 links. OK, so hopefully you're excited. So let's solve a real problem that I faced. So imagine you have a nice, simple case class representing a business model, in this case, a user. A user has an ID, a name, email, and a registration time. Now you're designing a REST API. And you guys are writing Scala. Like, OK, I have to write the case class to say what the shape of the output of the get API looks like. So you define a user get. OK, you get back the ID, you get back the name, and you get back the email. Well, let's say you have like some post API to create a user. So when you create a user, obviously, you don't have the ID. It's generated by your backend, by your database or something. But you need to provide name and email for sure. And patches are things where you can do partial updates of a model. And the patch, you can say, like, I only can update the name and the email. And these are optional. So OK, you wrote this. But you can see that it's kind of repetitive. If you have like 50 models, you have to maintain. There's also put another, which I didn't put on the slide. So you have to maintain 4 times 50, 200 case classes. And that seems kind of copy-paste and troublesome. And what happens if I change the type? If I change email to an email class instead of a string class, then I have to go, I mean, nice thing, we live in a static world, static compilation world. Well, I'll just go fix the compilation errors manually. But still, that's a repetitive, boring work. OK, can we do better? So here's what I want ideally. Ideally, I want to put an annotation called resource on my case class. And I want to say what things are available via what APIs. For example, I want to say the ID, you can only read it during the get call, the get API. The name, you can read it during the get, but you need to supply it during the post. And you can also do a partial update on it. So there's an add get, add post, add patch on the name. For the email, you cannot change your email address because, no, you registered with an email. That's the one you get. So you need to register with it. So you have a post on it, and you also get back. When you read the user back from your backend, it could be a database layer, some data access layer, you get the email back. And the registered time is something that is only available to your backend. You don't want to make it available to your REST API at all. So this has no annotation on it. So given this nice, pretty-looking user model, I want to generate this code. I want to generate a case class get with all the things that are gettable, a case class post with the things that are returned by the post API, and a case class patch. But the patch, I want to be a little clever when I want to make since patch, if you're familiar, you can do partial updates. You don't have to update everything in the field, unlike a put where you need to update everything. So in patch, I want to put options on all the types. So in this case, I want to only update the name, and I put option string with the default arguments of none. OK, so let's get this live coding started. OK. Can you guys see? All right. So I didn't do a lot of setup before this live coding. I know it's a short talk, so I did a little bit of setup. So the thing is, so let's look at the build.sbt. It's a brand new SBT project. I'm using Scala 2.12. I added the Scala Meta Paradise plugin. And I only depend on Scala test to write my unit test for this purpose of the talk. And I depend on Scala Meta 1.8. There's a newer Scala Meta out, but for the purpose of this talk, it doesn't change anything. It will work.
Can you make your font a little bigger?
Yes. OK. All right. Everyone can see in the back? Yes. OK, cool. Thanks. Yeah, so provided means that you don't need Scala Meta as a runtime dependency of your application. You only need it to provide it to you during compilation. You can remove it, then it becomes available as a runtime dependency, but that's just not needed. Because when macros are run only during the compilation phase, you don't need Scala Meta during the runtime of your application. So that's what provided means. Yeah, that's it. This is build.sbt. I have nothing funny going on. So this is the test. I wrote this before I started the talk to not waste time. I literally copy-pasted this case class, put it here. I'm using Scala tests should compile. I'm saying if I manage to make this work, user.get should compile, and user.post should compile, and user.patch with a partial update should compile. And this put should not compile because I didn't declare any put here. So it's just a test. And while we live code, our goal is to make the test pass. Now it's complaining like it doesn't recognize any of these annotations. So OK, let's start by creating those annotations. So I'll call it the resource. No. All right. Increase the font. Actually, even before I start, so let's start SBT. OK, so I'm doing clean test with a tilde in front. What the tilde does is watches your directory as you code. Why do I need clean? Because when I'm changing the macro code, the Scala compiler is not aware that you might be actually changing the source code. And so you need to always clean. Because in this particular case, I'm modifying the macro code. But if you're not touching the macro code, you obviously don't need clean. You can just do tilde test. So in this case, since I'm changing macro, I'll do that. And let's see. Yeah, I get the same compilation errors that IntelliJ is telling me that all these annotations, it doesn't know anything about them. OK. OK, so let's create our first. Can you guys see in the back? Cool. OK, so let's create the resource annotation. OK, that's that one. And let's create the restful annotations, which are class get extends annotation. And there's 4 of them, post, put, patch. You don't actually need a one for the delete API because you don't specify anything in the body, hopefully. OK. And well, that should make it recognize the verbs at least. Yeah. So now I'm getting the error saying value get is not a member of object user. So I haven't actually generated this get class. Okay, let's start. The magic would happen in the resource annotation, because that's the only the annotation which has access to the whole case class. Like this get only sees what it's annotating, in this case the constructor argument ID. Okay, so this is where the incantation comes in from Scala Meta. So import scala.meta. Okay, inline def apply, and this is the tree, and you return a new tree, and you use this. So this is the incantation needed to define a Scala Meta annotation macro. Okay, so in this particular case, definition is a tree, so I can return it, and this code would compile. So let's try that. So this shouldn't do anything. Yeah. Okay. Extend. Oh, static annotation. So it should be static annotation. There we go. Yeah, that gives me the same compile error. But you can, let's see if this actually got invoked or not. I'll use my favorite debugging tool for print line. Let's see if what does it print. Look at that. It printed the case class. This is the tree this is the class that I was annotating. That's very cool. I got my compiler to print something. Okay. So I need to first get this companion object out. And there are two cases. The companion object may already exist, or it may not. So you might have to create one on the fly. And how do I pattern match? So there is this very nice cheat sheet which tells you for anything, for how do you create a class, how you create an object, and you can use it both to create new things, new classes, new objects, or to pattern match your existing abstract syntax tree to do something. So in this particular case, I will pattern match on the definition. So it must be two cases. One, so it's the quasi-code. It's either a class followed. So this is the pattern for a class followed by its companion object. Okay. And this is the other case when the companion object is not defined.
Is this lexical matching? So if you had the companion object before.
Yeah, it's not like the companion object could be defined before, after. There could be something in the middle. But this by the time you get here, you have that's a very good question. It doesn't actually matter that the companion object is defined in the next line after the class definition ends. It doesn't matter. It is defined as a valid companion object. You get. This is the pattern match for that, because by the time you get to the abstract syntax tree, which at the phase at which the annotations run, you have all that information nicely collected for you. Yeah, and again, there's a cheat sheet linked, which links all these different quasi-codes to use. So, okay, so let's see, what should we do? So I want to get the class and the companion from this definition. For in this case, when the companion is already defined, it's simple. I just return the object and the class. In this case, I have to materialize a new companion object. And the way I do it is very simple. It's, again, use the quasi-code. Instead of pattern matching, you use it to materialize it. So in this case, it would be object. It would take the same name as the class, because that's how it is, class.name, and that's it. OK. So let's see what the compiler is saying. So the compiler is saying found type.name required term.name. That makes sense, because the class name is a type. When you declare a new class, you declare a new type. But when you declare a new object, you don't declare a new type. You declare a new term, like a val. An object is a val. OK, fine. So all these constructors have really useful, all these ADTs have very useful constructors. So I will create a new term. I need a term.name. And it says, OK, expected stream actual. So it needs like an actual string parameter. So there's always a value on everything. So OK, and let's print line class and the companion. So in this test, I didn't have a companion object. I just had the resource class. So I should have materialized I should have materialized companion by now. OK, let's see. Yep, voila. Look, I just created an empty companion object user. OK, that's progress. All right. OK. So now I have this companion object. I need to create all these case classes for every annotation inside it. So I need to go through all the annotations like this get, post, put, patch on the user's constructors arguments. OK. So it's actually very easy. Like if you have autocomplete, so it's like, OK, I want to look at the constructor. How do I look at the constructor? So you start typing, OK, ctor. That's what it's called. That's constructor, and its type is constructor.primary, because you could have secondary constructors. For the purpose of this live coding, let's go with the primary constructor. And I want to look at all the arguments or the parameters to the constructor, because that's what these are for a case class. These are parameters to the constructor. So they should have something called params. It says params SS. The reason for that is you can curry constructor parameters in Scala. Just as you can have multiple parameter list for a definition, you can have multiple parameter list for a constructor. Again, for the purpose of this live talk, I don't care about that. I'm just going to flatten them. So I just pretend I just have one giant uncurried parameter list. OK. So let's print line that. I want to see what's there. Yeah, OK. So I get back a list of, I got the list of all the constructor parameters with all the annotations, the names, and the type. Looks like progress. OK. So let's start our for comprehension. So these are my params, or param. And I want to get the annotation for these params. So how do I do that? I haven't actually showed you how to use this cheat sheet. It's Command F. Annotation. Oh, there we go. So this is the quasi code to get the annotation to both. Again, quasi codes are used in two ways: to both destructure, unapply, pattern match, or to create new things in your world. So in this case, you have the mod string interpolator, and you do this add thing. OK. Fine. So we go to param dot modifiers. So the modifiers of a parameter could be access control modifiers, public, private, protected. It could be annotations. So that's what they're called, modifiers. So let's go through each modifier. And for the purpose of this talk, we're only interested in the modifiers if they are these get, post, put, patch annotations. So here we would pattern match for an annotation. And we saw that the pattern match for an annotation is this mod thing. So we'll do mod at get, or mod at put, or mod at post, or mod, what's the other one? Patch. There we go. So this is the thing that we are interested in. So we will return this parameter now. If there's anything else, we don't care. Like if there's like any other annotation or any other parameter which doesn't have annotation, we don't care. So none. And let's call it the new param, or something that we're interested in. OK. And we will yield the modifier, saying this modifier is on this new parameter. So nothing here is complicated. It's just basic Scala I'm writing at this point, pattern matching. And let's assign it to a variable, I don't know, params or something. And favorite debugging tool, OK. OK, that's pretty cool. I got saying get is on the ID. OK, this is awkward because I have get twice, because when I returned the parameter, it returned with the annotation on it. I don't want that. So all these ADTs, abstract data types, to represent nodes in your abstract syntax tree, they are case classes. So you can write plain old Scala to modify them. So in this case, I want to copy pretty much the whole parameter, but I want to nuke all its modifiers, because I don't want the annotation on it. Like if I have a get on the ID, I don't want another get on this ID. I just want to get rid of that annotation on the ID parameter. So I will just say copy it, remove all its annotation. So perfect. So now I got back what I want: get ID, get name. Okay. So what I have essentially is a sequence of modifier, which is the annotation, to the parameter, which is the arguments to the constructor. So I want to group them. I want to get all the gets together, get all the posts together, got all the patches together to create these case classes. So well, what I essentially want to do is I want to go from a sequence of a comma b to a map of a comma sequence of b. I really wish this util was in the Scala collections library, because there is a to map on a sequence of tuples, but it just gives you a map of a comma b, which is almost never what I want. Because I want a multi-map. I don't want to just randomly pick collisions. OK, anyway, yeah, I will do that. So I will do, let's call it grouped params.group by the first thing. But then the map values, I have to pick the second thing. So yeah. This little util I always add it to my implicit sequence tuple thing, because this is such a common thing you have to do to go from sequence of AB to map to a multi-map. I usually call it .to multi-map. But yeah, this is basic Scala data structure manipulations. I hope this line doesn't trip you up. OK, so now I got the thing in a nicer format. I got it in a multi-map, which is given a sequence, given an annotation, what are the things that are annotating? What are all the parameters that have the get annotation? So let's print out grouped. Okay. Whoops, it didn't work. So it looks like it didn't actually do the group by, because this has a separate element for each get. It makes sense if you think about it. So what's happening is every node in the abstract syntax tree are by default not equal to each other. The very fact there is a get annotation on ID and a get annotation on name makes them different annotations. So this makes sense. Like, these are different things. They should have their equality on them should be a equality by reference, not by value. So OK, so what do I do? At this point, I don't care. I'm just going to do .toString. Live coding. OK, this actually fixed my thing. I collected, because since I did a toString, and the strings equality is defined as you'd expect. So I got all the parameters that have a post in it, all the parameters have a patch in it, and all the parameters that have a get in it. This is close to where I want to be. OK, so my grouped at this point is a map of string to the sequence of terms. OK, so map. So I want to, for each element in that, I want to create new case classes. So what I have, so this is the annotation, and these are the parameters. So I want to create a new case class. How do I create a new case class? Well, cheat sheet. How do I create a class? OK, so this is how you use the Q string interpolator. This mods means you can. It's like a string splat thing that got borrowed from JavaScript or something, but it's basically saying that you can put multiple modifiers. You can put public annotation. Then you put class, type name, which is the name of the class. New classes are new types. These are type parameters. Again, it's a ... because you could have multiple type parameters. These are constructor modifiers. Again, you can make your constructors of your class public or private. And these are triple params, because again, parameters of a class it's params, the plural of params, apparently. And this triple dot on it. Because parameters of a class, again, could be curried. You can define multiple parameter lists. And it extends template is Scala Meta's way of saying something like a body or something else. So they use template. So again, all of these are non-optional, obviously, but this is how you define a new class. OK, so I want to define a new class. So Q case class. I'll give it some class name. I don't know yet what. So class name, I don't know, some string. I haven't figured it out yet. And the parameters are going to be the same. So I'll use the dot dot dollar params. OK, so let's see, what should class name be? Class name should be just the annotation at this point, right? This is this at post. I have to remove the at from the beginning. So strip prefix. Oops, strip prefix, the at, and I want to capitalize it. So these are all utils that are in the nice Scala string implicit string library. So you can do all these things. OK, so it's complaining something. It's saying, hey, your class name is a string. You need a type.name. OK, again, we know that we can create those nodes in the abstract syntax tree very easily. So we do type.name and pass in the class name. OK, that compiles. And let's see, we'll call them the, I don't know, new classes or something. Let's print line the new classes. Yeah, this worked beautifully. It created a case class post with name, email, a case class get with ID. OK, this is good progress. I just need to stick this list of classes that I created in the companion object. OK, and again, how do we do that? Again, these companion object is itself a node in the abstract syntax tree. These are proper case classes. You can copy, you can do deep copies and change things in them. So I do have the companion object from up here that I haven't used yet. So I will do companion. I just want to modify its body. We know the body is called the template. OK, we have to do this deep copy thing. OK, what do I want to override in the template? OK, let's see. Dot copy. And again, how do I know all this? This is just hitting Command P in IntelliJ to see what else I can do, or looking at the cheat sheet. But in this case, I will pretend that I didn't know, and I'll hit Command P in IntelliJ, which shows all the parameters that I can do in the copy. So I can modify the early initializers. These are some weird feature of Scala that most people don't know about or shouldn't know about. They're going to be gone in future versions of Scala, so forget about it. Parents, yeah, makes sense. OK, you can have an object extending object. You can have a self parameter. Objects can have a self type. And stats. So stats is the body. I don't know why it's called stats, but that is the only thing that could be the body. OK, so stats. So I had to do like get the current stats, which is inside the body. It could be empty, so get or else nil, and just append my new classes to it. And it's an option, so to do some. OK, all right, and let's return the new companion object. I mean, that's the only thing new we are adding. We're not changing the case class, so you can you can return only the new things too, and that would work. OK, let's see. It worked. Almost. It's the patch API. OK, so this is going to be tricky. So remember, the patch is an optional update. So what I do is, it's not as simple as the get and post, where I take the name of the parameter and the type of the parameter, I just plonk it in. Here, the types that go into the patch case class are slightly special. I surround them with options, and I put a default argument none in them. So I need to handle that. OK, so that's up here. OK, so we have to handle patch annotation slightly special. So we put an add patch. We remove that from here. So OK, I need to return something. OK, how do I create a new parameter? Cheat sheet. How do I create a new parameter? No, not those. Oh, there we go. There are two kinds of parameters, type parameters and term parameters. This is a term parameter, obviously. So you use the param string interpolator. Again, parameters can have modifiers, name, the type, and the default argument. OK, all right. That looks exactly like something I need. So param, the name is going to be the exact same name of my current parameter. So param.name. It's going to be option some type. I don't know that yet. Equal to none. That's what I want to essentially return with the option of the type of this parameter. So OK, so so the type should be this params type. So there we go. I just type and something comes up that probably makes sense. There we go. The declared type. OK, so this is funny because declared type is optional. That's because pieces of the Scala, the abstracts in this ADT that's exposed to us as Scala programmers is reused in different parts of the language. So you could have somewhere in the language where you don't have to specify the types, and it's inferred, or it could be a generic. So it's an optional type. But that doesn't fly here, because this needs a type, and I have an optional type. So I will do something that you guys would love. I'm going to do a get on an option. It still doesn't like it, because it says, OK, I expected type, and actual is type.arg. OK, this is because it's a type argument. OK, fine. I'll do something else that you're going to love, as instance of. OK, before I get booed out of here, let me explain why this is OK. So we all, as Scala programmers, hate doing a get and an option or doing a typecast, because you get runtime failures. But the runtime failure of a macro is during your compilation phase. No big deal. So you can do ugly, ugly things in your macro code, because your runtime failure is during the compilation phase, so nothing bad can happen. So don't quote me on that, but yes. All right, OK. That seems about what I want. And well, yep, green, test pass. That's the end. And we can go back to the here, and I can actually I can remove this should compile for the things that should compile. I can copy it, and I can create those things here. IntelliJ doesn't know that this user.get is materialized, but we can see that the code still compiles. Yeah. And if I remove something, it will say that, hey, it's invalid because I didn't specify the email parameter. So this is real stuff. This get is being materialized and is available for you. I believe there is something here. No, doesn't do that. OK. They used to have some button here. You click, and it would show you things being materialized, but doesn't always work. But that's just an IDE issue. Scala Meta macro works beautifully. OK, yeah, this is it. I mean, this is what, 40 lines of code during live coding. And it's not that bad. It's something that's super useful. So imagine you can take it to the next level. You can imagine you have a data access layer, and you can generate all the CRUD, create, replace, update, delete APIs for your data access layer, where you want to get by ID, create, replace. And you can do a generation of the full code. You can generate SQL. You can generate caching and all that. You can take it to the next level. We won't have time for problem 2, obviously. It's basically a lens macro. You remember I had to do all these copy, 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 copy. There's ways when if you put an annotation on the def, you can reduce. You don't have to do all this. OK, and the code is up on GitHub. So the problem 1 is in that repo. Problem 2 is in the second one. I'll put these slides up. And last but not least, we're recruiting. I work at a hedge fund. We do a lot of Scala, Spark, big data analysis to trade on the stock market. So come talk to me if you're interested. That sounds cool. Yep, that was it.